Hi there, Mr. Tabitha. Yeah, this is me. I'm. This is the first. This is the first video, first lesson, and I'm just picking up where we left off, which is. Oh, let me take this to the. Well, actually, let me go ahead and take you to Moodle here because I added a couple of things there. It is a temporary online course policy and discussion forum. This course policy is just a continuation of this, basically. Just read through that. I'm not gonna read through it. I'm just supposed to have it there because since this class was used to be a face-to-face class and it's now an online class, they require this of me. So I added that in a discussion forum. The discussion forum is what we're gonna use. You just remember to read on your own the course policy there. For the discussion forum, the only thing we're going to do here is on Thursdays. That's what this means. It means that on Thursdays at let me see if I can see the time here. Two. Oh no. Anyway, no, it doesn't say. It doesn't say here. It's on the syllabus, on the policy, in the course policy. It says that we need to meet Thursdays. Well, we don't need to meet, but I'm gonna be available on Thursdays at from two to 3 o'clock. Like, if you have any questions, you don't have to click on this on what is the link to the remote classroom meeting. Well, I'm going to click on it. So anyway, I'm in the in Moodle, and then I just went to the course, Introductory Algebra, the MTH 100. Just go ahead and find yours and go into. Remember to read the course policy, and then go into the classroom discussion forum. It's the title. Click on it like I did, and then just on Thursday you can click on this link there, and then once you're here, just go ahead and join Hangout Meet here. Click on Join Hangouts Meet, and that'll take you to well, I'm gonna be in that. It's called study room, classroom. Yeah, classroom meeting. All it is just me and being connected to being available for students, and then students asking questions if they have any. In that way, we can, if I need to write something down, I could do that through the meeting, because I could share my I could share my screen like I'm about to do here. Watch. I could do this. See? Now I'm sharing my screen, and well, I will have to click on share screen, but it's gonna look something like this. Okay, and then you are able to see my screen. Okay, and if you need me to work out a problem like this, on my piece of paper, just let me know on Thursday from 2 to 3. Like I said, you don't have to assist that meeting. It's just for it's one of the requirements, from taking a face-to-face class to an online class. Okay, just remember. If you can remember how to get here, just watch the video again. Okay. Anyway, that's all I have here on Pearson. I'm not gonna show you, but you already know how to get to your assignments. So on Pearson, we're still gonna be doing the same thing there. We're gonna go into the assignments and finish those. Practice just like you've been doing, and finish those. It says that some of those are overdue already, but I left them open. So just go in there, open them up. You should be able to work the problems. If you have any trouble doing it, let me know, and I could reset the dates. But I don't. I shouldn't. It shouldn't be. You shouldn't have any problems trying to work out those overdue assignments. So just work on your own time and finish them whenever you can. Well, I mean, before the semester's over, right? Okay. And that is that. Let's see what else. Well, we are on. We left off on. Oh, let me share my screen again here. We left off here in section 8.1, 8.2, 8.3. So that's what I'm picking up. Let me see. I thought I needed to say something else before I started, but I'm drawing a blank. But if I remember, I will email it to you. Okay, I will email you that information. Okay, so let's go ahead and get started here. Let me just make sure that we are recording. Yeah, we are. Okay. So anyway, let me go back here, and this is the beginning of section 8.1. Section 8.1, 8.2, and 8.3. That's the lesson for today. For this section anyway. You know most of this stuff already, because all it is using the multiplication and the addition rules for and the ones you've been using. It's nothing really new. We're gonna add a few things, just very few things. You should have been able to finish this assignment on your own, but I don't know what happened there. But anyway, the only I guess the only thing that we're gonna be adding that it's fairly new is a set of real numbers. What the definition for a set of real numbers, and you are gonna have to learn the names, these names here. Oh yeah, I remember. For the to find the sections, just go to your ebook. Remember, just go to the multimedia library and look for the right section, and chapter and section, and just choose either textbook or video, and you're gonna find them there. In case they're not on the main page anymore, and just go in there and find them. And so this is where I'm getting everything from, as you already know. But you don't have to. If I move too fast here, just go back to your ebook and find this table here. Okay, it's gonna be in there. And yeah, you do have to memorize this as best you can, because I'm gonna test you. I'm gonna test you just a little bit on this, and not too much. Might have one or two problems asking you about this. It is important, because once you take the next whatever math you have to take next, you are gonna see these names here. You're gonna be dealing with these names, so you have to be familiar with them here. You don't necessarily have to be an expert at it once you get done this semester, but it is a good thing, to get familiar with these names and what they mean. Okay, and again, this is the set of real numbers, and you can find the table in section 8.1. For this, though, I'm gonna start here, because this little table, it's the next page, 613. It's on the next page, and it shows the real numbers. It boxes them neatly, and it shows you how. And forgive me if I don't flow here, because I am talking to myself here. So it's not like I'm teaching a class here, and then I'm not gonna have I won't be able to have interaction with you. I won't be able to see if you're getting the material or not. I won't be able to give you a chance to practice. So I'm just want to move along, but it's gonna be a little different. But just keep in mind that I'm juggling a lot of stuff, and so if I go too fast, all you have to do is just go back, on rewind the video and go back to whatever section you need additional help with. Okay. Anyway, the set of real numbers. Set of real numbers. There are two sets of numbers: the real numbers and the imaginary numbers. We are not going to deal with imaginary numbers in this section. Okay. Just so you know, all we're dealing with is the real numbers in this class. Notice how the real numbers are composed of two different kinds of numbers: the irrational and the rational numbers. Okay, irrational and rational numbers. Notice that the rational numbers are composed of the integers and the whole numbers and the natural numbers. And notice that the integers are composed of the whole numbers and the natural numbers. And notice that the whole numbers are composed of the whole numbers and the natural numbers. Okay. So these sections are boxed in well, it depends on which kind of numbers are you trying to learn. Just look at this section, and then I would suggest go back over here for the meaning of those numbers, for an example of these numbers. So I'm just going to keep it here close by. And then see, because now I can see that, the real numbers are composed of irrational numbers and rational numbers. Okay, then I go here and take a look at the irrational numbers and the rational numbers. That means that the irrational numbers are composed of only irrational numbers. Okay, so this by themselves, rational numbers. So there's no way that you can make irrational numbers out of any of this. No, can't. Okay, because that's what this table is telling you. Okay. And then I would suggest you learn this separately. So leave it, either learn it first or at the end. I'm going to take you back over to the rational numbers here. Rational numbers. And notice how the rational numbers are composed of the integers, the whole numbers, and the natural numbers. So what I would do is I would start learning the natural numbers first, because it's easier that way. Because notice how the natural numbers are only the numbers, the counting numbers, they call them the counting numbers, because they only, over here, because they only include the numbers 1, 2, 3, 4, 5, and so on, all the way to positive infinity. Okay, positive infinity, not negative. Okay, and notice how they start with the number 1. Okay, and I believe I told you that already. We did practice this some at the beginning, and that's why we needed to do it, because there was this lesson again. I knew we're gonna hit this lesson. Anyway, and then I would suggest you learn the whole numbers. Remember the names. This is the natural or counting numbers. This is the whole numbers. Whole numbers. Notice how it has an O there. I represent that to be the 0 there. That is included with the whole numbers, and that's how I know that Whole numbers are just positive values, including the zero. Whole numbers are the natural numbers, including the zero. Okay, if we go to the box over here, natural numbers are whole numbers. I mean, the whole numbers are natural numbers. Natural numbers, but you include the zero there. All right, so what about integers? Integers are composed of these two. So integers are composed of these two. But they also include negative values, okay? So negative values. And of course, you're going to include the zero because they include whole numbers too. Okay, so those are called the integers. You're probably familiar with that term already. And then the rational numbers. Rational numbers are fractions, basically, are fractions. However, remember that rational numbers are composed of integers, whole numbers, and natural numbers. Integers, whole numbers, natural numbers. Why is that? Because you can make any integer just with a fraction, because, like, for example, 2/2 is 1. See, they write it as a rational number, but it's the same thing as an integer. That's the integer 1. So make sure you relate rational numbers as being integers, whole numbers, and natural numbers. Okay, and remember that you can make up integers, whole numbers, and natural numbers with fractions or rational numbers. Rational. It's a ration. That's the way I remember it. That's the way I remember the name. It is a ration because you ration one part up here and one part down here. That's a good way to memorize that name. Rational numbers, because they ration. Anyway, that's the way I help myself memorize that name. Rational numbers also include, though, so they don't just include integers, whole numbers, natural numbers. Okay, they also include decimals. Okay, because remember, a fraction can be written as decimal. Okay, it could be terminating decimal or a continuous decimal. Remember how to write the continuation there, like with the bar at the end, on top of the whatever integer repeats or whatever set of integer repeats. Okay. So again, rational numbers also include decimals, terminating decimals, or continuing decimals. Okay, they can be positive or negative, but they do include positive. Terminating decimals and continuing decimals. And so the difference between rational numbers and irrational numbers is going to be here with continuing decimals. See, because irrational numbers are continuing decimals. Rational numbers are continuing decimals, and so are rational numbers. What is the difference, though? The difference is that rational numbers repeats. Rational numbers repeat. If you have a decimal that is continuous, it must repeat in order for it to be a rational number. Okay. Irrational numbers also repeat. However, the decimal doesn't repeat. That's the only difference. Okay. That is the only difference. Irrational numbers do not terminate. They repeat. They are continuous and do not repeat. Okay, and they're also written. And these are a few examples of the way they're written. In algebra, you're gonna learn different ways of writing irrational numbers. But in this case, these are going to be a few of the examples: square roots, negative or positive. Okay, and then pi. You're familiar with pi. Pi is a continuous decimal that doesn't repeat. Okay, that is an irrational number. Okay, and that is it. That is it for that. Section. Well, actually, we need to practice a few because we need to see if there are a few tricks there that you might not be familiar with if you haven't had any practice. So let's go here. Let's go here to this example here. And this, I believe, this is the only problem the only kind of problem I have in the assignments. And I'm taking my time here because this is something fairly new. Okay, so let's go ahead and start this example. Consider the following set of numbers: -7, -3/4, 0, 0.6, and that decimal repeats. Square root of 5, pi, 7.3, and square root of 81. Okay. So list the numbers in the set that are natural numbers. Okay, so they started with the natural numbers, and then they went with the whole numbers, then the integers, the rational and irrational numbers, and then the real numbers. Exactly exactly the way we memorized them. Remember, we started with the natural numbers, whole numbers, and integers, and then we worked on the rational numbers, irrational, and the real numbers. Okay, so what are the natural numbers? Which of these are natural numbers? If you remember, natural numbers are the counting numbers, what we call counting numbers, and they start with the integer 1, and they move on up to positive infinity. Well, which of these are positive? Well, that's one's negative, that one's negative. That's not going to work. 0 is positive. However, 0 doesn't start with 1. So no, that's not a natural number. 0.6 is not an integer. It's a decimal. A square root of 5. I know that's it could be square root of 5 could be and I'm getting my calculator here. Could be an integer, but no, not an integer, whole number. Natural number. That's what we're working with. It could be a natural number, whole number, an integer. It depends. So for that, I'm gonna use a calculator. You won't be able to use a calculator. However, let me show you these two examples here, so you can see the difference. So you can see how you're going to need to do this in your head. Square root of 5. Square root of 5. I'm gonna go ahead and type in square root of 5 here, and let's see. And it says that it is decimal, and it doesn't end. It does not end. It is continuous, and therefore I know that that's not natural number. That's not a natural number. It is a decimal. However, if I type in square root of 81, see, square root of 81 is 9. But you probably already know that because 9 times 9 is 81, okay? So this is the way you need to identify, you need to, identify which, whether the number is natural or unnatural, well, an integer, or an irrational number, okay? Because you know that square root basically means what two numbers, what number multiplied by itself gives you that number there. Well, in this case, it's 9. 9 times 9, 81. Okay, and you shouldn't have any number, any big numbers. Okay, so just remember that you need to multiply a number by itself. Okay, what two numbers? Well, start with 1. 1 times 1 is just 1. So square root of 1 is just 1. Square root of 2 is 2. Square root of 4 is 2 because 2 times 2 is 4. And then 3 times 3 is 9. Square root of 9 is 3 because you multiply 3 times 3, and so on. Okay, so what am I trying to say? Well, that whenever you see a square root like this, don't count that as an irrational number right away. Okay, because you could very well convert that, into an integer, like we did here with the 81. Okay, so this is not a natural number. This is not a natural number either, because that's not even an integer. This is a decimal, so no, that's not it either. So I guess the only natural number is 81. Square root of 81. Okay, because square root of 81 is 9. Okay, so let's move on to whole numbers. Whole numbers are natural numbers, and they include 0. Okay, so we know that square root of 81 was a natural number. Well, that's also gonna be a whole number, and then 0 also, because a whole number start with 0. Okay, and that's it. And then I go to integers. I know that integers include natural numbers and whole numbers, so I know it's these two are going to be included in here. Which ones are integers? If we go in here, since integers include positive and negative integers, numbers. The only other one I can see is this one here. That's a -7, so that is included in there, and with the integers. And then for the rational numbers include integers, whole numbers, and natural numbers, right? So then I'm going to include that one, that one, and that one, and also fractions, either positive or negative. Well, positive, that's a negative value. Negative fraction there. So I'm going to include that one too. But remember that rational numbers could be represented as decimals too. So let's go to let's look at the decimals. The only decimals we have are these two, and this one is a terminating decimal. This one is also terminating decimal. So both of them are rational numbers because they terminate. Okay. Well, this one doesn't terminate, but it repeats. Yeah, this one terminates and this one doesn't. However, this one repeats. Okay. And the only difference between rational numbers and irrational numbers was that irrational numbers do not terminate and do not repeat. Do not terminate and do not repeat. So which are the only two that do that? Two numbers here that do that, that do not terminate and do not repeat? Well, these two. As we already saw, square root of 5 was a decimal, and it doesn't terminate, and pi doesn't terminate it either. And you should already know that. Okay. So irrational numbers are only these two, not any of this, because, like I told you already, irrational numbers are separate from rational numbers. Okay. And then if we try to find real numbers, well, remember that real numbers included all these numbers, okay? All these different numbers. So all of these are real numbers. Because like I told you, we're not gonna deal with imaginary numbers here in this class. We will in algebra a lot. yeah, we are gonna learn about imaginary numbers very thoroughly, very thoroughly. Anyway, that's the end of that lesson there. I mean, of that example. So let's kind of move on. And now here I'm going to move a bit faster. Anyway, I'm still on section 8.1, okay? And I'm just following the next example. Let me see. Just algebraic expression. Just algebraic expression. Just algebraic expressions. Oh, how many terms? Yeah, yeah. No, this is a good example here. Like I told you, you already know a lot about equations, and the only thing we're gonna do now is we're gonna learn a few terms that we need to add to work with equations. Okay, that's all we're doing here, and this is a good start. This is telling me how many terms are there in the algebraic expression, and of course you could read through this, to tell you all I'm about to tell you, right? But you could just play the video, because I'm about to tell you what all of this means, how you can get all of these answers. So let's start with A here. How many terms are there in the algebraic expression? How many terms? I believe we talked about terms before, and remember that I told you that terms were separated by either positive or negative signs in an expression. Well, if you can remember that, you should be able to tell where a term begins and where one ends and where the other one begins. Okay, just by looking at positive and negative signs. Okay, just positive and negative signs, not multiplication or division signs. Okay, because notice that there's a multiplication there. However, we do not separate the 4 from the x. Okay, the whole thing is one term. 4x is one term. 7 is one term. 5x, 5 times x is one term. Okay, so only look at the positive and negative values. I mean positive and negative signs, and that's how you can tell terms apart. Okay, so how many terms are there in the algebraic expression? 1, 2, 3. Just 3. Okay, what is the coefficient of the first term? Okay, I should have gotten let me get a highlighter, because you need to learn these words. Yeah, these terms there. That's the first one you need to learn. Terms separated by they are separated by either positive or negative signs. That's all. And then coefficients. Memorize that. What is the coefficient of the first term? Well, since we know that this is the first term, a coefficient is the constant, basically, the constant that's being multiplied times the variable. Okay, so this 4 is the coefficient of this term. Okay, so the answer here is 4. Yeah. And then what is the constant term? What is the constant term? Notice that you'd be tempted to say that this is a constant. However, this is being multiplied times that x. It's all included in one term. Okay, therefore that's not a constant. Okay, it is a coefficient when you have it included in one term. Okay, and then this is another term that you need to memorize. The constant term. That's the whole thing is one term. Okay. You need to memorize that. What is the constant term? The constant term it's a constant, and since it is separated by these two signs, it is one single term. That's why this 7 is a constant term. It's the constant term. Okay. All right. So let's move on to D. What are the like terms in the algebraic expression? That's another term you have to memorize. Like terms. Like terms. What are like terms in the algebraic expression? What are the like terms in the algebraic expression? And we already practiced that before. And so you should already know that 5x and 5x are like terms because x is to the power of 1, x is to the power of 1. Therefore, you can add those two, okay? And 7 doesn't have any like terms because 7 is a constant and there aren't any more constants there, okay? All right, moving on. Let's see how fast we can move here. 6:15. Not that one. No, you don't have to learn this. Well, I mean, there's a table here in page 616. You do not have to memorize the names, these names here. I'm gonna teach you what you need about that table here, and you don't have to memorize the names. I'm not gonna test you on that. So all that means, all that in that table there, all that means is, and I believe I already taught you this. You multiply when you multiply any kind of term, any however many terms you have, multiply them 1 times every single term inside the parentheses. However many terms you have to the left, you multiply times however many times you have inside the parentheses. Okay, so in this case, 5 times 4x minus 3, you multiply 5 times the first term, 5 times the second term. And same thing here. It doesn't make a difference how many terms you have inside. You need to multiply them times this value. 4 times x, 4 times 10, and 4 times 3y. Same thing with this. It's very similar to this scenario there, but only in reverse, okay? And that's all you have to learn about that. And you already know that, but I just have to point that out because it's important. And from there, I'm moving on to example 3. Combining like terms. Combining like terms. You should already know how to do this because we practiced it. I believe we practiced a few times. But if not, be able to determine which are like terms, okay? And what are the rules for that? First of all, terms are separated by positive or negative signs, okay? And then combine like terms. See if there are constants first. Here we don't have any constants. We have variables. All of these are variables, even though they have coefficients. Okay, remember that these are not constants. These are coefficients because they're together with a variable there. That is one term. That is one term. That's one term. That's one term. That's why they're called coefficients. Okay. And then you look at the letter, or whatever letter they give you. It doesn't make a difference. See if the letter is the same. If it is the same, then look at the power. You know, what power are they in? In this case, these two x's have a power of 1. So you should be able to combine those together, and just look at the sign and either add or subtract. Okay, and then just write them, add the coefficients, rewrite the x. Remember how I keep telling you to rewrite, to rewrite, in this case you add the coefficients and rewrite the x, okay? Do not write x squared, no, because you're not multiplying, okay? In this case you're adding, so just rewrite the x, 19x, okay? Okay, so for B, you have two different terms. However, they are like terms because that's an 8, that's an 8 too. Add coefficients. In this case, you're just subtracting. So 7 minus 2 is 5. And then rewrite the A. Okay, rewrite A, and you're done. Okay, that's how you combine like terms. Okay, and remember that if you have constants, just add them up. All right, what about example 3? For example 3, we need to group grouping and combining like terms. Yeah. What they mean by grouping is combining, basically, like terms. Okay, in this case, different terms are divided by these signs. Okay, and I see that I have two constants. So just combine those together. 5 plus 8, that's 13. And then I have 2x to the power of 1, so those are like terms. 7 plus 3, combine coefficients. Add coefficients. That's 10. Rewrite the x because you're not multiplying, you're adding. 10. The answer should be 10x plus 13. All right. Okay, so again here, the different terms are separated by positive signs in this case. And then I have x's here to the power of 1, so those are like terms. So that's why I combine I add 4 plus 2, that's 6x. Yeah, rewrite the x, so 6x. And then your y's, add them together because they add to the power of 1. And so add the coefficients. 7 plus 3 is 10, 10y. So 6x plus 10y. Okay. I'm moving on to example 5. Okay. Simplifying an algebraic expression. Simplifying here, you combine the methods you already use, you already learned. Okay. So what simplifying means is break it down, basically. Yeah, if that's the way you want to memorize that word. Simplifying means make it as simple as possible. Okay. So in this case, I already know that I have multiplication between this parenthesis and this 5. So I need to multiply that 5 times however many terms you have inside there. So in this case, I multiply 5 times 3x first. 5 times 3x, that's 15x. 5 times 7 is 35. Write it down. And rewrite your 6x. So now I'm here. Okay. And here I combine like terms. In this case, I have these two terms that are like terms. Add them up. You get 21. X. Rewrite your x. 21x. Rewrite your 35, and you're done because you can't simplify it any further. You don't have any more like terms, so you're done. All right. And like I told you, I don't know if I'm going fast or slow or what, because I don't have any feedback. But feel free to rewind, fast forward as much as you need to. Okay. Okay. So I'm moving on to example 6. Okay. So here we're still simplifying algebraic expressions. Okay. Remember this word here. We call this an expression, okay? Not an equation. If you don't have an equal sign in there, it's not called an equation. It's called an expression, okay? So that's what I'm doing here. I need to simplify this expression. So first thing I do is combine this parenthesis with this number outside. In this case, I'm multiplying, so I multiply times every single term inside the parentheses, which is what they did here. Multiply 6 times 2, that's 12. 6 times 14, 4 is 24. Rewrite your x and your y, okay? Oh, my bad. And then multiply 10 times 4x, that's 40. Rewrite your x. 10 times 3, that's 30. Rewrite your y, okay? And now we're here, okay? And then combine like terms. Just combine like terms. I have x's here to the power of 1, so those are like terms. Add the coefficients, that's 32, 52. Rewrite your x, and then combine your y's together. Add the coefficients, that's 54. Rewrite your y, and you're done, because you don't have any more like terms, okay? All right, let's move on to example 7. All right, let's see what we're doing here. We're simplifying algebraic expressions involving addition. We're still doing the same thing, except for remember that we've been including negative signs in there. Just positive negative signs together. I still use the same rules, okay? They haven't changed yet, okay? Let me move this out here. Good, that's better. Okay, so for A, if we need to simplify, all we can do is combine these terms if we can. In this case, we can, because we have x to the power of 1. And again, it's just a matter of either adding or subtracting, okay? In this case, I subtract 11 minus 7 because I have a negative sign there. So 11 minus 7 is 4, and then keep the sign. I get negative 4. Rewrite your x, negative 4x, okay? Okay, so for B, let me see if I have any. What I would do here is change the signs right away. See, remember, if you have 2 signs together, you should go ahead and change them. In this case, that's a negative sign, that's a negative sign, and that's it. Just combine like terms. I have y here, now negative y here. That's a subtraction, basically. 9 minus 7 is 2. Keep the sign, negative 2, and keep the y, negative 2y. And then for you z's, that's another subtraction, because remember that's a negative there. 15 minus 12 is 3, positive 3x, positive 3x, and you're done. Okay. Okay, for z, start multiplying. 3 times 7 is 21x. 3 times 8 is 24. And then, I should have changed this sign to a negative here first. But that's okay. I can do it here. And then just combine your combine like terms. I can see this x. My x's are going to be like terms. So subtract. 25 minus 21 is 4. Keep the sign of the largest value, so it's negative 4x. Yeah, negative 4x plus 24. All right, and we're done. All right, so let's move on. Example 8. Simplifying algebraic expressions involving subtractions. It's still we're still doing the same thing. We're just simplifying. Okay, so don't let this throw you off. You know, all that wording there. All right, so go ahead and combine this like terms. In this case, we have a subtraction here. 8 minus 3 is 5. Keep the sign of the largest value. Negative 5x. And then rewrite that 2, and you're done. 2, negative 5x. And then here, I have a y there, x here, and x here. In this case, we have two negative signs, so all we have to do is add them together and keep the sign. 4 plus 2 is 6, negative 6x. Negative 6x, write it down, and then combine your y's. That's a subtraction. 12 minus 9 is 3, and then keep the y. Keep your y and write it down. That's positive. That's a positive 3y. And you're done. That's it. All right, let's move on. Let's see what else we have here. And there's another table there. You don't have to learn anything, memorize anything from there. Okay. I'm gonna tell you exactly what you need to learn from that table here, which isn't much. It's all it is. It's rules. That's all it is. Okay. So again, simplify algebraic expressions. That's all we're doing. That's what we're doing in this section. Well, not all, but most of it. In this case, I have a constant there. I need to multiply that times the coefficient there. And that's negative 2 times 3. That's 6. Keep the sign. You got a negative 6. Rewrite your x. Negative 6x. Here we have two x's. So you can combine those by adding them up. 6 plus 1 is 7. Rewrite your x, you get 7x. And then again, you have like terms. Just subtract. 9 minus 8 is 1. Keep the negative sign of the 9. You get a negative 1a. Negative 1a. However, remember that this is not simplified enough. You need to simplify completely. Okay. So I will not take this answer. Okay. This is not the right answer. You need to simplify that even further. Okay. So the answer should be negative a. Okay. All right. What about D? Oh, go ahead and multiply those. Negative 3 times 2. That's negative 6x. Negative 3 times negative 5 is positive 15. And now we're here. And now from here, well, there's nothing else to do because we don't have any like terms here. So you're done. All right. So what about E? In this case, remember, think of this as being a negative 1 there, and you're multiplying. So negative 1 times 3y is negative 3y, and negative 1 times negative 8 is positive 8. Positive 8. Okay. Negative 3y. The answer is negative 3y plus 8. Okay. I don't know if you remember, but we the way we did this in a few problems was that we changed the signs of every single term inside the parentheses, basically. So because this positive 3 became a negative, and this negative 8 became a positive because we were multiplying a negative value there, negative 1. Okay. So all you have to do, if you can remember, is just change the signs inside the parentheses. Okay. All right. Let's move on to example 10. Again, we're still simplifying algebraic expressions. Okay. So in this case, the whole thing is one expression. Again, if you can multiply, go ahead and get rid of that parentheses by multiplying here first. 5. Notice that, yeah, we still use the rules for order operations. However, inside the parentheses, you can't do anything because 2y and 9, those are not like terms. So you cannot combine them together, okay? But yeah, we are technically still using order operations, okay? So don't let that throw you off. We are still using PEMDAS, okay? All right, so here I multiply 5 times 2y, which is 10y. 5 times negative 9 is negative 45. And again, here you can either think of this as being a negative 1 and multiply times the first term, which will give you that, and then multiply them in the second term, which will give you this. Or you could just change the signs of these two terms, say, and rewrite them. Just change the sign. And then from here, now we're here, just combine like terms. Yeah, you could start with your constants, you could start with your variables, it doesn't make a difference. In this case, I'm gonna start with they started with the variable, so that's what I'm gonna do. I'm gonna subtract 10 minus 9, that's 1, y. And then my constants, 45 minus 8 is 37. Keep the sign of the largest value, negative 37. The answer should be negative. Oh, I'm right here. Negative 37, okay. So I'm right here. And notice how we have two signs there. Just change that into a negative sign. And remember that this 1 times y is not simplified enough. You need to simplify it further to y. Just one the variable 1. So the answer is y, negative 37, not 1y, negative 37. Okay. All right. Let's move on. I think we're moving, progressing really fast here, so that's good. Okay, again, we're still simplifying. Remember the rules for order operations, okay? So let's see if we can still use them here. How do you work a problem like this? You start with the parentheses inside the parentheses. See, parentheses inside the parentheses, and start from there. Start working your way out. Okay, that's, I don't know if you remember, but we did practice that. Okay, so here I'm gonna start here. However, these two terms are not like terms, so I can't do anything to that. So I'm gonna need to move out here too, and I can see that I'm adding this plus this. However, I cannot add this plus this because I don't know what this is. However, I know that I can multiply this times this and this times that. That I can do. So I'm gonna head and start there. So that's what they did here. Multiply 6 times x, that's 6x squared. 6 times 2, that's negative 2, is negative 12. So now we are here. Rewrite everything. Remember, rewrite as much as you can. It doesn't take long, and it keeps you from making mistakes. Because now I can see clearly what my expression looks like. See? So I'm right here. So I know that I'm still working inside this parenthesis here. Okay. And remember that this is a bracket. However, you can think of it as a parenthesis. Okay. Okay, here, do I have any like terms? Only these two. So go ahead and combine together. They combine out to negative 7. Negative 7. Rewrite everything else with including the signs. Remember not to skip any signs because that's important. So now I'm here. And then from here I can see that I cannot combine this and this because this 6x squared is inside this parenthesis. So I need to get rid of that parenthesis somehow. In this case, I'm multiplying negative 1 times all of this. In other words, I'm just changing the signs of these two terms. So that's what I did here. Change that sign, change the sign, rewrite everything else. Okay? And then from here, combine like terms. See, now I can combine this x squared and this x squared by basically subtracting. 18 minus 6 is 12, positive 12x squared. Okay, rewrite your x squared. Notice how this x is square, square, and this x is also square, not to the power of 1. Okay, because x to the power of 1 would not be like term to this two. Okay, and then add 4 and 7 because those are constants. Constants are like terms. You should remember that. 7 plus 4 is 11. And you're done because there aren't any more like terms. So that should be the answer. All right. And this, all this was a combination of what you already know, all the rules that you've learned. We only added a few more terms, which was the term coefficient, term, and they are found in page 614 if you need to review them. Terms, coefficient, constant term, okay? Because these two different things, okay? Terms and constant term are two different things, okay? And then like terms, okay? Make sure you memorize those, and that's it for section 8.1. So let me move on to section 8.2. This should go a bit faster, but let's see how fast I can make this go. Because we should be familiar with these concepts already. Okay, so I'm going to go ahead and jump to example 1 right away. Reviewing the addition property. We don't have to review it, but let's say you had a problem like this in your assignment, which asks you to solve the equation. Remember that you either use the addition property of equality or the multiplication property of equality. In this case, it's the addition. Okay, addition property of equality, which calls for either adding or subtracting, depending on the sign here, depending on the sign or the operation. In this case, you are subtracting, so it's an operation, and so you're subtracting. So add 5. Just add 5 to both sides, and you're gonna get x one side and 50 on the other, and you're done. Once you get x by itself, you're done. Okay. Notice that if you get any coefficient with the x here, you're still not done. Okay, you still have to use the multiplication principle and get rid of the whatever other values are on this side of the with the x. Okay, x need to be by itself in order for you to be done. Okay, in order for you to have solved the equation. Okay, or else it's not going to be correct. All right, let me go ahead and move on to example 2. And like I said, you already know this, okay? So shouldn't be new. Again, here it and my screen froze. Oh, hold on. Yeah, it's back. And then here let me check my recording here because I don't know if I'm still recording. Yeah, it looks like I'm still recording. So what I was saying here is that I don't think I have that many or any problems with decimals in your assignments. I'm not completely sure. I think I omitted them all. But if you do, it shouldn't be a hard problem. See, because that's what I'm trying to avoid. I'm trying to avoid, you have to spend a lot of time just doing subtraction and addition of decimals. Since I already know you know how to do this, so you probably won't find a problem like this with decimals in there. Okay. And in this case, if you did, all you had to do is use the addition property of equality, which calls for subtracting here 0.14 from both sides. Okay, yeah, you have to keep it balanced, so do it to both sides, and you're done. Okay, let's move on to example 3. Again, since I already know that you know how to work with fractions. If I give you an example problem like this in the assignments, it would take a lot. It would waste your time because all I'm testing you on now is to see if you can solve for x, for the missing variable. Okay, so I don't think you're gonna I don't think I added any fraction problems like this, you know. But if you did, just work use either the addition or the multiplication principle. In this section, we're looking at the addition principle. So that's the property. So that's the property you're gonna use, the addition property. So in this case, I have a subtraction here. Just add the number you're trying to move to both sides. Okay, add the number you're trying to move to both sides, and you're done. Well, in this case, you still have to simplify. Okay, on this side. Okay, but you should already know how to do that. Okay, in this case, we have a common denominator here. So just add the numerators, and you're done. All right, let's move on. And we're almost done with this section. Well, no, not really. No, but it's not. It shouldn't be that complicated anyway. Well, we sort of are, because all it is combining like terms, which we already know how to do. In this case, just go ahead and combine these y's and constants together. See, which would get you all the way to here, and here just use the addition property of equality and add the number you're trying to move to both sides. That's it, and you're done. All right. In this case, well, now this is still okay. Okay, I see what they're doing here, because now we have these two terms in two different sides. Of the equation. So we need to combine them together. And then here, students ask me, where am I supposed to isolate the variable? On the right side or on the left side? And I tell them it doesn't really matter. However, remember that in algebra, we're used to isolating the variable on the left side, but sometimes we do isolate it on the right side. Because remember that it doesn't matter if you isolate it on the right or the left, because if you isolate it on the right side, you just at the end just switch both terms from one side to the other, and the answer the variable should be on the left side. What do I mean by that? For example, here, if I isolated the variable on the right side like this, then at the end there, I would just move this x to the left side and that 7 to the right side, and this still means the same thing as this. Okay, and I have isolated my variable on the left and not on the right. So it doesn't really make a difference. However, if you start isolating them on the left side, that would be even better, I think. Just so you can get so you can make it a habit. That's all. Here, if I'm gonna do that, then I'm gonna have to move that 3x over to that side by using the addition principle. So it still works the same. You use the addition principle. In this case, I'm gonna have to subtract the number I'm trying to move, or the term. In this case, because notice how we're moving a whole term together. Okay, not just the coefficients. In this case, we were able to move the whole term together, okay, to the other side, okay? And then just add or subtract. In this case, you get x equals 7, okay? Okay, so that's the only other thing they threw in here, that we, let's see, that we are able to move a whole term from one side to the other, okay? So we can do that too, okay? Not just constants, okay? We can move whole terms. As long as they're separated by a positive or negative sign, move that term. You can move it, move it from one side to the other. It's fine. All right. That was the only thing they added there. So let's move on to example 6. Okay, so solving an equation by isolating the variable. Yeah. So that's exactly what we're doing. Oh, and we're working with equations now too. And so, but just remember that we're still using the addition. We could use the addition or the multiplication properties of equalities. In this case, and again, it doesn't make a difference where you isolate the variable. I'm going to go ahead and do it on the left side. So I'm going to subtract. Since this is a positive 2y, and remember that you can move terms from one side to the other. Just subtract 2y from both sides. Subtract 2y from both sides. You get y equals 9. I mean, y minus 9 equals 6. And in this case, like I told you, you are not done if you have either a coefficient or another term in there in that side with the variable. You are not done yet. You need to isolate the variable by itself. That's exactly what that means. In this case, just add 9 to both sides. Add 9 to both sides, and you're done. Y is by itself. And I'm not gonna check any problems. Double check. You could, yeah, and you should, but I'm not gonna do it because we don't have time. But it's a good thing, good practice to do it. But from experience in my algebra class, in my algebra classes, we rarely ever check answers like this because of time constraints. It just we don't have enough time. Okay. And that's why I'm not doing it here either, because I know that I don't have that much time either left. And like I told you before, I'm not gonna assign you any word problems. If you can make an A on the practice problems I assign you, you should be okay. Okay. And this is good practice for algebra, even for algebra. Okay. So you should be ready once you go from here to the second part of algebra. Then you should be ready for that part, and then once you go from there into the algebra class, you should be ready for the algebra class. So just continue practicing like we're doing. Okay. All right. So let me go ahead and move on to section 8.3, which I already did. I'm already here. So I'm going to start in example 1. So all this is we're working with the multiplication property of equality. Okay, that's all we're doing. But you already know how to do this. You've practiced this before. Okay, so I'm right here. The only thing is that they throw different scenarios at us. That's all it is. But you should be able to theoretically, you should be able to solve for x even in these kinds of scenarios. Okay, because what does this mean? This line means division. Okay, so you're dividing here, and what does multiplication property of equality call for? To either multiply or divide, depending on the operation here, on whichever side. It doesn't make a difference. So in this case, I see that if I want to isolate my variable x, I'm gonna and I'm dividing by 5. I'm going to have to use the multiplication property of equality and multiply times 5. I do that to both sides to keep it balanced. 5, you could either think of this as dividing 5 by 5, that's 1. 1 times x is just x. Or you can multiply 5 times x and then divide 5 by 5, which is the same thing I did. You're going to get a 1x, which is the same thing as x. And then multiply 5 times 9, that's 45. And you're done. Okay. So yeah, this probably looks familiar to you already. So that's good. That's not a problem. And but let's see if they give us any different scenarios from somewhere over here. Okay, in this case, we're multiplying here, right? And we need x by itself. We need to divide both sides by x, by 6. Then you're gonna get x equals 30 divided by 6, which is 5. So x equals 5. For b, same thing, except for here they introduced a negative sign there. Okay, so remember that in order for us to do this in one step, we're going to have to include negative signs too. So if I'm dividing by 7, I'm going to have to divide by -7. Because remember that dividing a negative by a negative gives you a positive. That's why I need to include the negative there, the negative sign. So it's going to look something like this. See, the -7, which is what we're trying to move. That term there, coefficient, we're trying to move that. Therefore, we need to include the whole thing, even the sign with it, to move it in one step. Because we could do 2 steps, but that's just a waste of time. So if you can remember to include the sign, we can do it in one step. In this case, divide that out, or cross it out actually, and just write y, and then divide 56, positive 56 by a -7, you get a -8. Okay, and you're done. Okay, what about this number? That's a decimal. I'm not gonna mess with that, like I told you before. Okay, because all I'm doing now is just trying to get you to practice the addition and multiplication property of equalities. Okay, so let's go ahead and here we still deal with fractions. However, remember that you could think of this fraction as being multiplied times y. Okay, so if I'm multiplying, well, then all I have to do is divide by 3/4, right? In this case, in this time, I'm gonna have to write it down because you need to see what I'm doing. In this case, if I divide 12 by 3/4, that means the same thing as dividing it this way, right? 3/4, right? Yeah, and I will write it this way because remember that this is the way we worked it out. This is the way we worked out fractions. So this might look familiar to you. Instead of doing it like this is too complicated. Because see, from here, now we multiply times the reciprocal of 3/4, which is 4/3. And I'm done with that. I can scratch it. Remember to include the multiplication sign there. And now you're ready to multiply across. However, if you can simplify before you multiply, you can remember that rule, that would be awesome. Because here I can divide 3 divided by 3, that's 1. 12 divided by 3 is 4. 4 times 4 is 12. 1 times 1 is just 1. I'm just writing it down just so I can make a point of it. So because there's a 1 here, multiply times 1, you get 1, right? However, this is not simplified enough. You need to simplify it as much as you can, okay? So the answer will be this. All right. Let me go ahead and work out the next one. And move this over here. There you go. Here, I'm trying to move, remember that you need to move the whole thing in one step by including the sign, okay? So since I'm multiplying -3/5 times x, I need to divide everything by -3/5. I'm not gonna do it to this side because I know that's gonna go away, okay? If I'm including the sign, it's gonna go away, and it's gonna end up with a positive. Yeah, we're going to end up with a positive x here. And so I'm not going to do it to that side. I'm going to do it to the other side. 9 divided by a negative 3 over 5. However, it would be better if you write it this way, by a negative 3 over 5. Okay. And then from here, and I would include signs here, parentheses here, if you want to keep the sign together. That way you don't get confused. And from here, just find the reciprocal of negative 3 over 5, which is negative 5 over 3. Oops, made a mess there. Negative 5 over 3, and multiply. Get rid of that. And simplify. Simplify before you multiply. Remember the rule? That's 3 divided by 3, that's 1. 9 divided by 3 is 3. 3 times 5, or negative 5, is negative 15 over 1, which is the same thing as negative 15. Okay, so the answer is negative 15. All right. And I do believe I included examples like this in the assignment, even though you're going to be dealing with fractions. But that's because it is important to practice moving whole fractions. Because notice that we could have moved this 5 over to this side first, and then the 3. But then that makes more work. It's two different steps there instead of just one. That's why I'm gonna include fractions in these kinds of problems whenever you're using the multiplication property. All right, let's move on. And I don't know how long this it's looking like a long video, but that's probably because of the introduction. But that's okay. You should be able to fast forward and rewind as you need to. Once you look at the whole video, then you can fast forward and rewind as much as you need to. All right, so let's see example 4. Example 4 calls for solving equations in the form of negative x equals c. Okay, so in this case, it's similar to getting rid of parentheses like this, 3x plus 5. Remember how you multiply this? You can think of this as being a negative 1, and then multiply times that term, and then times that term. Or in other words, just changing the sign, changing the signs inside the parentheses of those terms. That's basically what you do. That's basically what that ends up doing whenever you multiply numbers like this, negative ones like this. Well, something similar happens here. Oh, there it is. It's right there. You can think of moving a negative 1 from the x by multiplying times a negative 1. You could either multiply or subtract. It doesn't make a difference. Divide. But think of this example here, and something similar is happening there. It's not the same, but it's similar because all that's gonna end up happening is you're gonna change the signs of all these terms. Okay, if you have a negative x, if you want to change it to a positive, change the signs of the however many terms you have on this side. Okay, it doesn't make a difference how many terms you have on that side. Change them. Okay, so let me give you an example here. If I have a negative x there, equals 5y plus z minus 12. Okay. If I'm trying to get rid of that negative sign there with the x, I change every single sign. That's all I do. That's what ends up happening. That's so. Just go ahead and change the signs. Rewrite everything else, but change the signs. That's the easiest way to do it. Because remember that you multiply times 1. That's what it does. And since you're doing it to both sides, since you're doing it to both sides, what happens here when you multiply times -1? Oops, this is what's going on. You're multiplying times every single term. Okay, you're multiplying times the whole side. Therefore, you multiply times every single term. And that's why every sign changes. Okay, because you multiply times the whole side, not just times one of the terms. You multiply times the whole side, which is the rule, which is basically the rule for algebraic expressions, for solving algebraic expressions. Algebraic equations. What was I about to say? The thing is, you haven't seen. You haven't seen. I don't think you have seen any. We haven't worked any problems this difficult yet. Any equations, anyway. Okay, so let's move on. Same thing with this. Just remember to change the signs of every single term on this side. In this case, the answer will be positive there. Positive 7. Yeah, positive 7 will be the answer. Oh, right there. All right, so let's move on to example 8. Example 5. Using both addition and multiplication properties. Okay, so now we're using addition and multiplication properties. Still, use the same knowledge that you already know. You should be able to solve x for x easily. Okay. I'm not gonna work this out because you already know how to do this. Because think about it. We're trying to isolate the variable on one side. Well, it's already on the left, so just leave this term here. Deal with this by using the addition property and add 28 to both sides, and then use the multiplication property and divide by -2, both sides by -2, and you're done. Okay, so I'm not even going to worry about showing you examples using both multiplication and addition properties. Okay. Again, you still the goal is the same, to isolate the variable on one side. So in this case, just bring this -2 to this side by using the addition property. And remember that you are able to move whole terms. Okay, you're able to move whole terms from one side to the other. Okay, so in this case, you move the whole term, not just a -2. Okay, like we do sometimes. In this case, you need to move the whole term, which is -2x, over to this side by adding 2x to both sides. Okay, adding 2x to both sides, and then you're here, and then from here, just use the addition principle property to add 14 to both sides, and then you're here. Then use the multiplication property, divide both sides by 5, and your answer should be 4. Okay, and so you should be able to use the multiplication and addition properties of equality together. Okay, and again, I'm not going to worry about including. I have included word problems before, but not too much. That's okay. In this case, I'm not gonna worry about that because it's a lot of work. The assignment. So anyway, that's the end of that, and you should be able to do the assignments for 8.1, 8.2, 8.3, and I will see you on the next. And I will try to add a lesson or a video every day from now on. In that way, you can just run at your own pace. Okay. Okay. And again, if you have any questions, you either email me or call me. My office phone number. And remember that I'm gonna be available on Thursdays from 2 to 3. If you have any questions, I'm gonna be in there. I have to. You don't have to. You don't have to ask any question. You have to go to the meeting room. You can skip it altogether. That's fine. That's not a problem. But I will be there. I should be there on Thursdays from 2 to 3. Okay. And if you want to see me work out a problem by hand. Okay. All right. If you have any questions, let me know. Bye.